Mm-hmm.
Hello all, welcome to another session of SD Skills. Today we are going to do a mock interview. Prem is the interviewer and Chiranjeev is a mock candidate. They would be going through 45 minutes or 50 minutes for the interview, and followed by there would be quick feedback section, and then folks can go deep dive if they want on the technical topic. With this, over to Prem and Chiranjeev.
Hi, Chiranjeev. Welcome to XYZ company. Yeah, are you okay? Shall we start the interview now?
Yeah, I think we can go ahead.
Yep, sure. Yeah, the question is for today's interview session, we have to design a service like Google Drive or Dropbox, which allow user to store their data securely and synchronized and effectively on the remote server. User should be able to download and upload files from their devices. So user can have multiple devices. So we need to, we need to synchronize with all the devices. And the system should be highly available and reliable and scalable. Do you have any questions?
Yeah, I think I understood the question. So, yeah, the question is that we want to, this file sharing or hosting system like Google Drive, right? And Dropbox. I got it.
Yeah.
And mhm. and mhm. Sure, makes sense. And we want to make it. You said we should be highly available, scalable, and multiple devices should be synchronized if they are uploading at the same time. Right. Okay. So
Yep.
I can go ahead and list out the some requirements. So if I have to, sorry, not here. If I have to double click and then write some requirements. So yeah, we should have requirements. Uh, so user should be able to upload, right? That's the basic fundamental.
Yep. Upload and download.
Upload a file or folder, right? Actually, no, they can
Just
just
file.
upload a file.
Yeah, file.
Yeah,
Yeah, file is good enough. Yeah.
right. And they can upload down. Okay, download the same file. D4WN. Download files. And what else can they do? Can they update a file? No, I don't think so.
Yeah, they
Um,
can edit. They can edit and save it. Once they do edit and save it, then it will be automatically synchronized with other devices.
right. Synchronized uh, among user devices. Okay.
So one requirement here is we don't need to share files to other user. So don't consider that as a requirement. But however, we have to synchronize within user devices. Yeah, because user may be having 4 or 5 devices, so we need to do the synchronization. But don't consider for now. I mean, this particular thing, right? Design, you don't need to consider for sharing files among other users. Yeah, that is not required for now. Yeah.
Right. Yeah, that makes sense. Um, so we should have upload, download, edit, save, and what else can they do with the file? Um, they can rename a file, maybe. I don't know. Is that
That
required?
that is not required. You don't worry. I mean, basically, edit, save. I mean, when you do rename, that means like you're deleting it and basically you're just changing it, right? So don't worry about that for now. And
Right.
the basic requirement, just upload, download, delete, and should be synchronized with other devices
Right.
for same user. And probably we
Mm-hmm.
can have one more requirement like versioning and history of the file. That's all. Probably
Versioning.
that's all
Yeah.
for now. Yeah.
versioning. Okay, version, they can write, they can have multiple version of a file. Okay, so we should have some non-functional as well, I guess. Non-functional. So it should be highly available system. So that means, I mean, if the file is uploaded, user should be able to. Uh, I mean, it should be as much as possible available, 99.999 or whatever. Um, it should be what else? It said synchronization. It looks like it's a functional requirement now. Is there anything related to consistency? Of course, I think
Yeah. Yep.
we
Yep.
can just
It
start.
should be. Yeah, it should be consistency. Basically, whatever we do, it should be atomic.
Right,
Yeah, atomic
right, right,
consistent. Basically, we need to follow that as it rule. Yeah.
right. And also upload and download in terms of latency or something like that. We don't have to. I mean, it will take as much as it needs, right? I mean,
Yeah,
can you
depending
download?
on the bandwidth. So yeah, that you don't need to worry. That, yeah.
Yeah, acceptable latency. Okay, so that is something that durability. Yeah, definitely, we must have this durability thing. Once the file is persisted, user should be able to get it. So we definitely um okay, we should have acceptable latency, durability, consistency. System should be available. System. Okay, I think this should be. Do we need some more security? Okay. Um, file sharing. You said that not required. So obviously,
Yeah.
yeah, we can go without that. Um, does that look acceptable? I think to you, or do we need to
Yeah,
include some more?
looks good. I think for this discussion, this looks good only.
Mm-hmm.
Yeah, we
Right,
can
right,
move on to next one. Yeah.
right. Okay, makes sense. So we can move on to the next one. So in terms of bandwidth, you mentioned uh, what should be our number. So in terms of bandwidth, in terms of the scale of the system, we can assume that we have some users, some number of users.
Yeah, now for this discussion, like we can say, like we have around 100 million active user. I mean,
Mhm.
basically, yeah, we have around 100 million user, and the active user should be like maybe 50 million. We can say,
Right. Okay, yeah, I
right?
think that. Right. Yeah, I think that makes sense. 100 million users and 50 million active users.
Yeah, each
Uh,
user maybe maybe around like 100 files, just average 100 files per user. Yeah, and each file size maybe 1 MB.
right. 1 MB average file size. Right. Okay, I think that makes sense. 1 MB of average file size, so total size. So we have 100 million. Okay, 50 million active user. They are all okay. Sorry, 100 million total users. They all want to upload their files. Let's say 100, and they each file on average should be 1 MB of file, and this is M. So that will become 10,000. That means 10,000 million um, bytes of file. Um, कितना million megabytes of file. That will be, I don't know how much will that be. Um, So that will be looks like, yeah,
Yeah, this is just, I mean, this is storage, right? So maybe yeah,
right.
you can say, yeah, space, yeah.
Yeah, yeah. So this will be, this looks like a lot actually. Even with 1 MB, it looks like, so M is 10 raised to the power 6, right? So it will become, first let me convert it to gig. So 10 raised to the power 4 times, uh, 10 raised to the power 6. This is the count, and this is MB. So if I reduce here, this will become GB. If I reduce this, then this will become terabyte. This much, sorry, this much terabyte of data. Okay, yeah, this much terabyte, and if I reduce this one, this will become 1, then this will become petabyte, 10 petabytes of data. Okay, yeah.
Yeah.
So this much storage we need. Let me remove this one actually, because this is no longer required. And in terms of bandwidth, so
So we can
uh,
assume that like, read rate, right? 1:1 ratio, right?
mhm,
50 million active user in that, like 1:1, right? Yeah, that's good enough.
yeah, read write 1 is to 150 million active users, and so this is just for, okay. So 50 million active users means they all want to store and upload in a
They,
single day.
anytime, like, 50 million active users are there, anyone can, do write or read, right? So the ratio here is like 1:1. That means one person reading and one person writing, right? Yeah.
Right, right. Okay. So since we have 50 million active users, the total, uh, and they don't want to upload 100 files every day, right? These 100
No.
files is over a period of time, like over their entire lifetime,
Yeah.
is what
Yeah.
we are
Yeah.
assuming.
Yeah.
So for the system, we have 10 terabyte of total storage that your system would need, and um, and for bandwidth, which is our download upload, basically, um,
Basically, traffic
speed,
estimation. Yeah.
traffic
For read
estimation,
rate
right?
speed. Yeah.
Right,
Exactly.
right. Right. So for that, 50 million users would they be uploading 100 files every day, like every time? I don't think so.
They
This
don't
will
do
be
like that, but just don't assume, yeah, each user, writing one file, right, at
right,
a time.
right. Yeah, that makes sense. So they will, let's say, all each 50 million users can upload or download one file. So that means 1 MB, MB data at a time. So this will become about uh, 50 times 10 to the power 6 MB. So this will become terabyte. This much terabyte of data per second. Actually, not per second,
No, per second, per day, right? Yeah.
per day. Yeah, you're
Yeah.
right.
Yeah.
This will become per day. Yeah. So in terms of per second, we need this much divided by. Do we need to calculate this? 3600 times 24, I guess. 24 hours. 1 hour is 3600 seconds. So this much, uh, you know, this much data per second. This is per day, so this will become per second. So this will become this much terabyte per second. So if we calculate this, it will become, if I, yeah, and we can do that quickly. So let me just do this and just multiply this by 1000. So this will become, and then again 1000. So it's coming out to be 578, 578, 578, roughly 500. This is MB per second. Okay, yeah. So this is the bandwidth that the server needs, right? Because they have to process the every 50 million users files to restore the system. Does that make sense? Or am I making any mistake here? Roughly 1
Okay, I
gig.
think,
Mhm.
no, 1 G per second, is it? It's true. Okay. Yeah, I mean,
This is not for user. This is for server, I guess, because what, right? This is for the web server. I mean the system, because it has to accept all the users, every user's files into the system. So it will go through a common channel, which is a server, right?
yeah, it's for overall, probably like for a
Overall,
given point of time. Yeah, for a given point of time, right? You know, how the user is, going to read and write. That's also a matter, right? When you consider traffic estimation, because
Mhm.
you're calculating overall but need not update entire 1 MB at a time, right? He may be writing like a few chunk of data, right, per
Right,
second.
right, right, right,
Yeah,
right, right. Yep. So we need to
yeah,
break it down. Yeah,
yeah.
the system cannot.
Yeah, user cannot write everything like 1 MB at a time, right? So you may be writing a few chunk, right?
Mhm.
That's what we need to consider. Yeah, that's what is missing. Yeah, I think yeah, that's the
Makes
only
sense.
thing. Yeah.
Mm-hmm. Makes sense. Okay. So I think at this point, the user would be, I mean, the system. So we have to assume that what is the bandwidth we are allowing, so that, so depending on that, we'll have, the file uploaded, download time, different file upload and download time. So we have assumed that this, yeah, they will immediately start uploading for all the 1 MB file, and if we have this much overall bandwidth, the entire file will get uploaded in a single second.
Yeah, this is true, but actually, file upload, download, one thing, but usually, this is a file share, right? Basically, user wanted to do edit or, change some content, right? So in that
Mhm.
case, he need not upload the entire thing, right? He just, had to
Right,
modify a few chunk in a particular location, right?
right.
Yeah, yeah.
So
So
right, right. Okay, so well, in that case, this number will not be, I think, so much relevant here, because that will keep changing depending on whether it's upload or it's just some update on the file. That also, that is also something that we'll have to consider at a later stage. So I think I will leave that here and move on to a high level design.
okay.
How do I- So overall, I think at a high level we should have a client, which is, you can have multiple clients here, not this one. Okay, so let's say I have uh, a web server here, and then we have a couple of clients. Um, how do I make a client? Okay, I will just write it down. So let's say we have a web client, which user can upload a file directly from web browser, or user can upload a, from mobile devices maybe. You said there may be multiple other clients.
Yeah.
maybe tablet devices and other devices, their request will be coming to a web server, and then we have to. So actually, on the client side also, we should have uh, uh, there will be a logic to basically break down this file into multiple chunks, and and that chunks will be uploaded to web server, and then web server should persist it to a data store. So overall, we should have a data storage. So I don't know where to draw that. Is there a thing where I can draw a database or something?
No, I think you can just make it up, just put some, just, add it
Something
and
like this.
name it. Yeah, that's fine.
Okay, assuming that, yeah, this is my uh, storage, file, or let's say, yeah, file or maybe block storage. So we should have something like that. Yeah, so this storage basically what they will store all the individual chunks of files, and then we should have overall a web server. This web server will communicate to this. So the users can basically here upload or upload, download, and obviously edit also. And this will be the persistent storage where file will be stored. We should also have the metadata server actually, because each file will have its own metadata related to files. So let's me make a copy of this. This, and then let's make it here. So let's say we have a metadata storage. Okay, so overall, this is what we should have. Here we'll have a metadata details of a file. The user can, the web server can definitely uh, you know, talk to metadata, and
Should be some relationship between metadata storage and file storage, right? Or
uh,
how you're going to handle?
yeah, so each metadata will have some, yeah, definitely there should be a link between metadata and a file. So yeah, we should have this so that metadata will have location of the file on a file storage. Yeah, I think that
Okay.
makes sense. And we should have, I think, we can obviously have a couple of caching layer in between. So that is for, make sure that we have acceptable latency. Uh, like metadata caching layer, and a separate caching layer for a file storage system also. So let's say here, then I'll have to move this little bit out, little bit here, and also let's move this thing a little bit here, and then make it a little bit. What I cannot make it smaller. Yeah, like this, and then this will go here, and then we should have something like this. So let me make it like this. Yeah, like this. Okay, so this is what we should have, and let me draw it
But
a little bit
but
here.
you created caching, then web server is directly talking to metadata storage as well. So then what is the use of caching there? Like there is no correlation between caching and metadata storage. It's like
So yeah, so this direct relation is because cache miss. So if web server is getting from caching and then data is not there, then it will basically go to metadata storage, find the data on the web server, and then basically update the caching again, caching server again, and then from cache, like it will retrieve, it can retrieve the data for read operations. So
how the caching will going to happen? If okay, when you try to read data, if not there, you are storing into metadata storage or
mhm,
file storage, but
mhm.
always the caching will be empty in that case, right? So how that data will be getting filled in caching system?
So web, I think the data on the caching server, it's a web server's responsibility to fill the data on the caching server. I mean, because let's say, so for the upload operation, I mean, the caching won't play any role because it has to upload, store all the data into metadata as well as in the block server, right, on the file storage. But for the uh, download operation, it can it can basically store for the first time. When if the data is not there, if there is only one client, first client is requesting, then obviously it will retrieve the data from storage, and will send it to client, and also upload it on the caching server, right, at the same time. And once it updates the cache, then it will have the data uh, for the next operation, for the next download. So that's what I'm saying. Like, I mean,
But then in that case, you're doing two operation, right? One to caching
yeah, you're
system,
right.
one
That's right.
then
That's right.
waste of. I mean, it's like it's a bandwidth. We need to consider bandwidth as well as a storage thing, right? So
Mhm.
why do you need to do both at a time?
Um, well, irrespective of, so let's say, I mean, even if you want to, let's say, if I switch from here to here, let's say if the caching directly talks to metadata storage, still there is another communication channel that cache will establish with the metadata storage anyway. So irrespective of whether we have this or this, there will be two network connections that will be established in order to get a file for any read operation anyway. That, is that not the case?
No, that's so. If I think you're doing a kind of doing duplicate thing, right? Maybe once you okay, I think you need to consider the effectiveness, right? Like for example, now you're uploading data to caching system as well as metadata storage. Then
Mm-hmm.
reading, how the system will know that reading, I have to look for from caching system, and how to distinguish. Basically, I think you're doing two operations, right? So that itself overkill. So that one we need to see. Then
We are
other thing
not
is,
doing two operations. We are not doing two operations. We are doing
mhm.
two operations only for the first time, like when the data, only for the cache miss case. Okay, so let me make it write it down here. This is cache miss. Does that make sense now? So for any cache hit, there is only one operation. It will never go to metadata storage uh, for any hit, cache hit case, or even for block storage. It will never go to the real block storage for the hit case. So only for the miss case is when it will directly contact the block storage case. So there is
Are you
only one
talking?
operation.
Are you considering only for reading or writing or both
Uh,
for this
for
scenario?
reading, yeah, you're right. For only for reading, only the caching will be helpful, right? For writing also, actually it may be helpful if the block is already present, or it for double, avoiding the double write, or if for synchronization, I think. But for reading, I was talking about.
Okay, I mean, and okay. Anyway, we will talk more on that. Maybe you proceed your idea. Then we will discuss in detail later. Yeah, you can move on.
Right.
For now. Yeah.
Sure. Okay. On the client end, I think that we should have, a system, which can basically, let me move it here. So on the client end, also we should have, each web client can, um, basically break down a file into multiple chunks and just store. Let's and then we can, upload all the blocks. Uh, so we should have a system. The client side also we should have a system over here, and then for the, let me make it here also. Okay, yeah, and then, for synchronization. So if one client already uploaded some file and we want that file to appear on the other client, immediately, uh, we should have a system, maybe event-driven system or something like that. So whenever upload happens, the system needs to know that there's a upload that has happened, and, uh, so maybe I can have another service for that. Let's say I have another, backend service. Let's say something like, synchronization service, maybe synchronization service. What this service will do is this will keep track of any new events, any new basically uploads, and, and so this guy will basically, talk to, uh, the main web server for any upload, and, and you know asynchronously, basically other than the real upload, it will start synchronizing with the other web clients. It will establish connections with other web client, and, basically, use some sort of, event driven, um, system, like, it will, so web server can, let's say, asynchronously drop a message on a SQS or somewhere, and from there the synchronization service will kick in and will start synchronizing with the other clients, and, that will be that. And, for editing, uh, I think since we have, if for editing, I think what we can do is, since the client will break down the file into multiple pieces, so individual blocks will be uploaded in. If there is a change in a block, then only, uh, then only that block will be stored on a block server. Otherwise, it can be reused. So, and the information about that can be uploaded on the metadata server. So the web server will basically, uh, change the metadata of the file with the, let's say, updation date and size and any other details, like a lot of, um, storage here. So let me, instead of storage, let me make it database. That would make more sense. Yeah. So that will be something that the web server has to do. And obviously for distributing the traffic, we should have a load balancer here. So let me make it something like, load balancer at this level. And, so we should definitely have a load balancer here, which will, uh, basically distribute all the traffic. And also for directly, yeah, and web server. So since we are storing file in, basically block storage, like individual blocks. Therefore, for downloading, we have to add these blocks to construct a file. So we should have a system for that as well. So in that case, what we should have is we should have a block file block storage service, let's say. So we already have a block storage, the real storage, and then we should have a uh, let's say block service of which will construct retrieve the files from blocks and basically construct a real file and then provide it to the client. So for that, let me make it available here, and then um, we should have a block service here. Block service here, and this guy will basically talk to the block storage to construct a file and provide it to the metadata web server, which can then send it to the client for any download operation. And um, and similarly for metadata storage, since user metadata database, since we have the a full database system format here, therefore we should also have a metadata service. So if user is just, let's say, not downloading but just trying to view the file, then it can get this data from metadata. So for that, I think what we can do is we can move it here, then here, and then we should also have metadata service. And this guy will basically talk to metadata. Actually, no. This guy will basically talk to metadata store database um, and also with the web server, so that that guy can just uh, just basically um, download um, the data. I mean, just provide the data to the different clients for viewing purposes. Yeah, and and between the metadata service and database, we can also have a cache at this layer, so that um, this data can be, to reduce, to offload some traffic and reduce latency. So we can have a caching layer here as well. Caching layer here as well, and also we should have a caching layer here. So we have multiple caches, and then and obviously for all the storage, we should have a couple of replications. The entire storage service can be regionalized. So that means uh, anything on one region. I mean, so that, I mean, so if we have, assuming that 50 million users are in just one region, then obviously it's already, everything is for one region. But if for scaling, we can just have a uh, replica of all the uh, storage for durability purposes. So we can make it here, like we can have multiple set of replica here. Multiple replications, and same thing for metadata database as well. So here also we should have something like that. Yeah. And then if you go back to our requirement, we should have upload, download, edit, save, versioning. Um, for versioning, we have to, I think we have to um, basically update a system on top of this. Um, so in the metadata database, we'll have to store a version number along with all the details. And for each version, so all the connections with the metadata storage to the block storage, that will be for that will increase for each version. So even for the same file reference, uh, the, there can be multiple entry, like multiple storage. Uh, I mean, each version will have its own storage on the block server. So, but then again, how the clients want to retrieve the older version, that is something that will be a separate system that we'll have to build. Maybe the client can, I don't know, roll back or something like that. What can client do in terms of versioning? Is
We
there
can
anything?
just just specifically like versioning number, right? I mean, it's not, we are not planning to maintain like version control kind of thing, but just know like, okay, the version number 1, it's saved, this is a date and time, and version number 2, this is a date and time. That's all. I think we don't need to take care of something similar to our Git system, Git repo. It is not a Git repo system, right? So once
Right,
you write it, it's right. That's all. It's the data. It's data. Whatever data is written, that's a final, right? We cannot go
right,
back. But however, when we changed and what we changed, I mean that details high level. That's good enough. Yeah,
right,
keeping it in metadata service. Yeah, that's good enough, just for recording purpose and not the
right.
content. Yeah.
Yeah. So metadata will always database will should obviously have the creation date and the updation date. So anytime there is an update, it will update that entry. And for versioning, I think, okay. So what can restore is that if the same file is let's say uploaded or changed 5 times, then maybe it can just keep another field that, okay, the same file name or something like that has been updated 5, so 1, 2, 3, something like that. So if that's the version, then probably it can store another field in the metadata base. I think if that makes sense. Um, what else? What else should we cover here? Synchronization. For synchronization, I think we already covered that there has to be a synchronization service, which will basically talk to all of the um, this will talk to web server and basically keep synchronizing with the client. So it will have to establish connection with uh, basically web server, I would say. So like this, and inform web server that there is gonna be a main there is a synchronization that's gonna happen, but that will not happen in a main request. It will happen separately, and it will follow uh, you know some sort of a notification system, um, which will then the web server can come establish connection with its clients, and then basically uh, synchronize all the available clients the user has.
I have a question here, like how you're doing synchronization between client. I think that part is not stated here. Yeah, synchronization. You saying synchronization service? Yeah, that's fine. But how it's getting notified to other devices?
Yeah, so what I'm saying is that the other devices, so it will have to establish a separate connection with uh, so what it can do is synchronization service will have list of all the clients, like for that user. And so and each client will then will basically make a notification, some sort of maybe um, push notification or something like that. And then it will, whenever that client is online, that client will basically, so every time a client is online, the client will make a connection to the, let's say, a separate service, which is a synchronization service. So every time a client is online, it will make a connection to this synchronization service, and then this service will basically take the latest state of uh, the entire all the files, and then we'll uh, communicate with the web server to communicate with the entire world, and then we'll basically directly delivers that file content to the uh, updated content on the client device.
I think so. Question here. So I think what you would have to in a Google Drive or a Dropbox, I think irrespective of how many clients a user has registered, there's always usually one client or basically one application of that user that's actually requesting it, right? So whatever is the payload that is requested, it only should go to that particular client, right? So I think you will need some kind of a lookup table that you'll need to maintain as a part of the synchronization service. And the synchronization service needs to be aware of what payload has been sent back to that client and only that client, and where it needs to be, where it stands, right? Because there's two data that's being transferred here, right? One is the block service, which is I mean, integrating all the different files together and basically sending them. And then the web server, which is basically streaming those payload back to the client, right? So I guess synchronization service needs to basically provide that service, if I'm understanding what you're trying to say. Yeah.
Yeah, that's right. Yeah, that's what I wanted to say. And so yeah, it has to have that list of all the devices. So I thought that I have structured out in the service, but let me make a note
Yeah.
of this. So I think,
And you
yeah,
also need an authentication service to I
right.
mean, so you know that what I mean, I guess these are things that you're, I mean, some people are fine with not going in detail with the authentication service, but more or less they would want one way or the other for the authentication, and to, if it is a new client, to basically know what those clients are, right? Because based upon the devices, I think that is also one direction that you can take an interviewer, because we are talking about different clients with different capacity to handle streaming, right? Some of the low inbound devices are something like a mobile, where you need to be careful about how you stream it, right? And that is the reason also why synchronization service is very important on where we stand in terms of queuing, what payload has been hacked and what not, right? So yeah, I mean, that's my quick feedback.
Then towards
Sorry.
yes, Chiranjeev, yeah, you can continue your discussion. Maybe once you are done with your design, we can talk quickly. Then we can move on to next. Just interest of time. Yeah.
Mhm. Yeah. So yeah, for authentication and authorization, we should obviously have
I think the requirement I did not give authentication authorization, so you don't need to consider,
mm,
because the objective here is just a single user. I mean,
right.
basically multiple user will be there, but we are not planning to share content between user.
Hmm.
So the synchronization will happen within own user devices only.
Right.
So that, I mean, just for the interest of time, you don't need to talk about authorization, authentication. That's a big, I mean, if you include everything, like, it's a big discussion, so let's not
Right.
go further. probably the idea here is like how the main objective here is right, how you're storing the file, how you're communicating to, how your synchronization doing, how you are doing synchronization between client, and what is the mechanism, uploading and downloading the file, how effectively you are doing this entire operation. That's the thing, we are more interested.
Makes sense. So yeah, what I'm saying is that the synchronization service will have its own, let's say a database for synchronization data. It will have per user all the devices and the connection information. I mean all the clients. Clients means if the user has 3 devices, I'm assuming that there are 3 clients, and then so what it can do is it can stream. So let's say, okay, so let's say it fetched from this lookup database that, okay, it has 3 devices. Then it can, and once the upload is completed, the web server will notify the synchronization service, and this synchronization service will basically stream this message that, okay, there was an upload that happened, or there was a deletion that has happened, something update that has happened. So need to synchronize. And if there are 3 clients, then we can have, let's say, 3 number of messages that it will deliver to 3 basically some sort of polars, and those polars will separately establish 3 connections with the web client. Well, not really established, but okay, so it doesn't need to establish, because the client, it has to deliver the content to client only when the client is on live. So once the other client is online, okay, yeah, that's the thing. So once the other client is online, then that client will have to, uh, talk to, let's say the client should talk to web server directly only. That's my take. So it shouldn't talk to any other service. So in that case, what it can do is there has to be another API on the web server side, just for synchronization purposes. So whenever the client is online, it will, let's say, talk to this guy web server. So that's the same API. Okay, and then the web server will basically validate whether this client has a missing content, and for that purpose, it will forward this request to um, synchronization service, and then this synchronization service will validate whether this client needs some update, and for that update, it will basically do all these thing that how many files are missing, what all new files that needs to be updated to the client, and um, yeah, and then deliver those content via uh, via a separate channel. So I'm thinking that I'm thinking that maybe that channel can be maybe can directly establish with the client also. And
okay, Sanjeev, I think just we're running out of time. So probably like now you done with the entire design, or still something pending?
I think, I'm not sure what is pending over here. So if you want me to discuss something, we can discuss.
That's fine. Probably like this is actually, you put it in high level design, right? So one part here, the most important thing for the entire system is, right, how we are chunking the file and how we are uploading it, right? So
Right.
that's one thing. Maybe that's a more, that's only, that's one thing we need to talk. And then we want to move on to,
Right. So for since 1 MB of file is I think it's a little bit bigger. We should have on the client end, we can have a system that this can break down the file into, let's say, 1 KB or something like that, or even smaller, depending on the requirement, and basically break down the file into a couple of chunks so that the individual chunks can be stored in parallel on a block storage, and and can be stored separately also on the block storage, so that this block service can make use of those chunks for construction. And all those data can be stored. The data of the chunks can be stored in the metadata storage. So this guy also has the the information about the chunk, all the and a file, so in a separate table, so that the construction can happen whenever the file needs to be synchronized or to be downloaded to the for the requested download. So that can happen. That should happen, I think, at the client end.
Okay. Okay. What else? So are you done with the design? Okay. So can you? Okay, that's fine. Can you maybe I think just because of interest of time, right? Can you just put like a small sequence diagram kind of thing, just for data flow
I think
from
we are
client
almost
EA?
at time. I think we should wrap up the interview
Yeah.
because it's almost like 1 hour. So typically 45 minutes is the max.
Yes. Yeah, probably like Chiranjeev, just final, quick, just 2 minutes, right? You just give a small walkthrough from your design aspect, like how the
For the
request
request
comes,
flow,
and yeah,
right,
just
right.
quickly. Yeah.
Sure, yeah. So let's say a client request makes a call to for upload. The upload path would be that this will go through the upload API, and this guy will basically, okay. So on the client side, we'll have this, once the upload is in progress, the client will, I mean, have multiple chunks of the files. These chunks will be uploaded to the web server. The web server will talk, to the storage, blog storage. The web server will check with construct a metadata of the file, like retrieve all the file creation date and everything, and stored it on the metadata storage. Will also check with individual pieces, individual chunks to the file, basically block storage, and then uh, uh, via a block service, of course, and then also notify for uh, any sort of synchronization. And for the download, whenever the client requests a download, the web server will basically request that there is a download. So it will call a block storage service, and then this guy will uh, for that file, it retrieve all the chunks, all the blocks from the block storage, and reconstruct uh, a file, and then delivers it to the client. It will also talk to metadata. The web server will also check with metadata service to make sure that the to validate and provide the information about the file to the client. And whenever a new device is online, then the device can talk to web server, and the web server will check if there is an update. So for that purpose, it will uh, communicate with the synchronization service, and this guy will basically delivers the basically checks the update of goes through the list of files and checks if there is an update on the file, uh, and then it will basically deliver the content uh, for the updated file um, on that client which is online. So each online client, I think, will have its own copy of the file.
Okay. Good. Sanjeev, probably you can wrap up. Yeah. So what's your feedback? What's your assessment, self-assessment from the your design aspect?
From the design aspect, from the design aspect, I think I don't know. I think we can have a little more diagram for the synchronization service, and we should also have I think a little more discussion or maybe aspect of the uh, basically this um, file for basically I think yeah, that's what I'm saying, that maybe for synchronization service we can have a little bit more in-depth discussion about how this synchronization happen, like when there are multiple devices online and they to both upload at the same time. So that part is something, and let's say they both have the same file, then which device will get to upload? Uh, that is something that is missing here.
Okay.
Yeah, and yeah, I don't know. Other than that part, yeah, we can have mhm.
Okay. I think okay. Yeah. So are you done?
Mhm.
Okay. Probably like okay. I will give my feedback quickly, and then we can give it to audience for rest of the feedback. Yeah, I think you started capturing requirements and doing estimation. I think well. Then when you enter into design, top level design, so the entire 45 minute session we have to cover top level design and APIs. Then of course we have to talk about low level design also. I know this is a big topic. Yeah, we cannot cover everything in 45 minutes, but at least the core, because if you see the requirements wise, we did not talk about multi-user and all, so you don't need to worry, but at least for a single user aspect, the objective here is to complete it, right? The main core essence of the design is like how efficiently you are uploading data, how efficiently you are editing data, how you are organizing metadata, and how you are organizing your block storage. So what is the relationship between metadata and the block storage? That's completely not stated. Then we already on top of that, yeah, we are bringing caching. Yeah, caching is good, but there should be some relationship between this is components, right? So that's not clearly stated. Yeah, the other part, I think you already agreed that the synchronization service is not very clearly stated, right? Yeah, so yeah, that's a thing I want to give feedback. Probably like you need to improve on a few things, like especially when you introduce new component, why we are introducing the component, what is the relationship, and how components are interacting each other. Yeah, those things probably you need to understand a bit more. Yeah,
Yeah,
then
makes
only
sense.
the entire flow, maybe once you design it, you yourself can think start from client. Okay, I am uploading a little content to the web server, how we are chunking the data. So first step, right? Second step, then now you're pushing data to block storage. And third step, how you're pushing data to metadata storage. Likewise, you just think 2 minutes, and then you'll get some idea, and based on that you can correct yourself, right?
Right.
That's something you need to, yeah, we need more practice session. Yeah.
Sure, sure. Thank you so much. I think that makes sense.
Okay.
Yeah, that's all
Thank
from my side.
you.
And number wise, yeah, so that's all. Probably we give to audience for other feedback, quick feedback, then we can stop the recording.
But yeah, thank you, Prem. Thank you, Chiranjeev. That was nice. Any other feedback from everyone?